Hello and very warm welcome to a new course on big data. So, one of the most emerging technologies and the future, of course, of our computing and way forward into the industry standards in terms of computer technologies and many other interdisciplinary fields and sectors where big data is an emerging hot term as of now. So what is big data? So in this lecture we'll be covering the basics of big data. How is it different from small data? How will it really impact our lives in the future? And would it be good or bad? So, data. What is essentially data? Any raw term figure is called data. Everything is data. We then confine it to some knowledge, to some information firstly. Like, so data is 54. 54 is the number of people over there. That becomes information, knowledge. So 54 people in the city are Christian, and out of 100 people, and the rest of them are Catholics. Then we gather some insights about what people say. In this manner, when we continue towards the life cycle of data, confining data into some information, interpreting the information into some knowledge to get some insight, and insight for some wisdom. Like a political analysis would be about what the people are, what are their beliefs and values, what are their expectations towards politics, what do they look for in a political leader, and how will our candidate can fit in their demands and essentially be the leader and help them govern the constitution. So that's political analysis. It can be used in various domains, and almost all of that. How will the company's future be affected? What are the market trends, etc. So to gather some insight and gain some wisdom, we need data, and we also need some tools and technologies to manage the data. So firstly, let us go step by step. So firstly, we make observations. What do we see in nature? Then thinking of some interesting questions that can arise. Then we formulate some sort of hypotheses over our questions to make a generalization about the causes of phenomenon or what we are wondering about. And if my hypothesis is correct, I expected A to happen in circumstances of B and give us a result C. Then we gather data to test predictions, whether our predictions will be correct or not, in which relevant data can come from literature, new observations, or even formal experiments. And we develop some general theories on how the data should be consistent with the most or the available data with other current theories. So this has been the traditional approach. We generated the hypotheses, assembled a sample population and a control group, exposed both to an intervention, drug or treatment, do a statistical analysis and identify the causal relationship, and rinse and repeat. And it was quite boring. So what emerged later was new database management systems that gave rise to big data that is too large or too complex. So relational database management systems like DBMS, SQL, so they were good enough for till 1 or 2 terabytes of data. When we go beyond that scale, when we're having like 50 terabytes of data, like Facebook generating every hour like 100 TB, 100 terabytes, you need some sort of scalable architecture, horizontally scalable. It should not be vertically scalable. So what do I mean by vertically scalable? So supposedly you are having an i7 processor. So to upgrade or increase the performance of your operating system and your processor, you need to upgrade to i9 processor, correct? So you have to sell out your i7 core processor and buy an i9 processor, which is quite costly. But if an alternative comes that you can attach another i7 core processor with your existing i7 or an i5 processor with your i7, and it can leverage the power of both of them and give you some sort of distributed computing, wouldn't that be more profitable? Whenever you run out of storage or performance, you just add another CPU and your storage and everything gets expanded, instead of buying a bigger, powerful, better GPU. So that is big data. When we are leveraging beyond the traditional data processing techniques and processing, analysis and storage techniques. So why did we move towards big data? Because of the volume at which our data is rising? Or how we can identify the need that we require, like an architecture or technology for big data? So the four main V's of big data are velocity, volume, variety, and veracity. So volume means scales of data. So when we talk about scales, we measure data in bytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes, zettabytes, and yottabyte. We are talking in terms of scales of data. So this is volume of data. So imagine you're having an i9 processor having, say, 10 gigabytes of RAM, and you then buy another same operating system, another GPU with, say, 10 gigabytes of RAM, and your RAM gets 20 gigabytes. That's horizontally scalable. So 90% of the data of today's data has been created in the just last 2 years. So we can imagine at the exponential of growth in volume of our data, like 90% of today's data has been created in the last 2 years. So there's a massive growth volume in the data. Every day we create around 2 trillion bytes of data, or enough to fill till 10 million Blu-ray CDs, compact discs. 40 zettabytes or trillion gigabytes will be created by 2020. We are already halfway through 2020. So like 20 zettabytes of data has been created. So we do well understand it's equivalent to 5200 gigabytes of data for every man and woman and child on earth. Most of the companies have over 10 terabytes of data stored. 100 terabytes, I'm so sorry. So a variety of forms of data that we are generating. LinkedIn's, Facebook, Spotify, WhatsApp. I guess every one of our students over here that are present obviously use WhatsApp, browse YouTube, Facebook, most kind of meeting, LinkedIn for searching for job profiles. That's also data we are generating to get job in big data. Instagram, Facebook, Flickr, Twitter. So analysis of these streaming data. Also stock market, another medium producing a lot of data every minute, every second. Banking, there's a transaction done every second. So we are generating lots and lots of data. So veracity, also known as trustworthiness of data. Origin, authenticity, trustworthiness, completeness, integrity. If our data is authentic, it's not some fake data, it's authentic data that we can study. It's trustworthy, that people give their trustworthy opinions. completeness, integrity. Data is in a good form. So volume, variety, veracity. So variety, we all have also already seen variety. So big data and research. So data mining, I guess everyone is over here understands data mining. We collect big data to obtain or access to a repository, perform some analysis to explore the patterns in our data, like mining data, generating insights out of our data. Pattern recognition, identifying the pattern of our stock market. Predictive analytics, where the market will go tomorrow or day after tomorrow. How much will the company earn in 10 years from now? Identify potential correlations, how their marketing strategy is correlated with their revenue. The better market strategy, better revenue. In healthcare, obviously we can see that we can use the patient's data, what the patient has been suffering for over some time, and give, like, predict whether the person is suffering from some common allergies or something. And increase inborn digital data, also storing birth certificates, sharing medical records. Each time the person doesn't have to carry their medical report to the hospital. Faster and cheaper technology and data storage. The cost to sequence a whole human genome sequence has fallen from 100 million to less than $1,000 over the past 15 years. That's used for gene editing. So discussion on our programming models. So why parallelizing our programs? So we need to parallelize our computing operation for better processing, like distributed computing, and parallel architectures. Form some traditional models on parallel programming, type parallel programs, message passing interfaces, and MapReduce. So we'll be covering all of these topics. So the MapReduce analytics engine. So let's discuss about the basics of MapReducing. That's used for in Google BigQuery as well as Hadoop distributed operating system. So on the verge of disruptive century, breakthroughs that we have gone through are gene sequencing and biotechnology, faster communication, smaller, faster and cheaper sensors, and ubiquitous computing. We are living in a world full of data. So these are the official records that we were just discussing. We need to store, access, process, share, and do much more on the data. These are the modern programming models, and some big examples could be Hadoop MapReduce, Google's Frego, and CMU's GraphLab. So Hadoop MapReduce. This is what we'll be discussing in our next lecture. Hope you guys understood this lecture, and we'll be discussing some more details about Hadoop distributed operating system in our next lectures. Hope you guys are clear with this lecture. See you guys in the next lecture. Happy learning.